Alright. Drug-resistant bacteria stymied by AI-designed antibiotics. Drug-resistant bacteria stymied by AI-designed antibiotics. You're listening to Drug-resistant bacteria stymied by AI-designed antibiotics, presented by Hakeem Alibokus Alexander on Noom Vibe and Spreaker, presented for HAKEYM News in association with World Reading Club and UniquilibriuM. This edition's reading focus comes to us from Genetic Engineering and Biotechnology News. It was published on the 24th of March 2024 and is published under the categories of artificial intelligence, drug-resistant bacteria, antibiotics. Alright, let's take a look. I've been using some AI a lot lately. Hey Daryl. By the way, I got your message in the back channels, and I did change the title. I changed it from having the branded name in the front to at the end. So it starts off, it says top coach interviews on, instead of starting with Noom Vibe first. So hopefully that helps. It was previously titled Wisdom Top Mentor Interviews when it was Wisdom, and then I changed it to Noom Top Coach Interviews, but I changed the wording. So when you do your SEO work or whatever you're doing with the branding, let me know if that changed anything, because I know I have a lot of stuff online and it pops up on Google and searches and stuff like that. So alright, moving on here. So this is drug-resistant bacteria stymied by AI-designed antibiotics. Who's the author here? I don't usually read a lot from this site for this news site for my podcast, so I'm not familiar with the setup as much as it is here, but we'll go through and take a look. There is a nice image with some bacteria, of course, that's on here, and the credit goes to Katerina Kohn from the Science Photo Library. Let's take a look. It says Stanford and McMaster University researchers created an artificial intelligence AI model to design molecules that inhibit the growth of Acinetobacter baumannii, a common drug-resistant bacteria. They synthesized and validated 6 structurally novel molecules that demonstrated antibacterial activity against A. baumannii and other phylogenetically diverse bacterial pathogens. This study represents a significant step toward the practical application of generative AI approaches for antibiotic discovery and drug discovery in general. The research article, Generative AI for Designing and Validating Easily Synthesizable and Structurally Novel Antibiotics, was published in Nature Machine Intelligence. Stopping Escape. Escape is ESKAPE. I'm guessing that's an acronym. We're going to discover what it means in a moment. All right. So among the most critical issues in contemporary medicine is the worldwide spread of factors contributing to antibiotic resistance. In 2019, drug-resistant infections were responsible for an estimated 4.95 million deaths, As new antibiotics are being developed slower than the spread of antimicrobial resistance determinants, this figure is expected to reach 10 million annually by 2050. I have to wonder that this is not necessarily some kind of sensationalism. And I mean that it's not, because this is a journal that I don't think a lot of people are reading. I mean, it's Genetic Engineering and Biotechnology News. I don't know. Maybe I don't look at these numbers enough, but that's kind of alarming to the numbers that in 2019 drug-resistant infections were responsible for an estimated 4.95 million deaths in 2019. Where's the news about that? In 2019, I mean, isn't that a pretty crazy number? 4.95 million deaths? 4,950,000 deaths. And this figure is expected to reach 10 million annually by 2050. All right, continuing. 6 bacterial species are particularly dangerous and resistant to drugs, known as the escape pathogens. According to the World Health Organization, one of these pathogens, the gram-negative bacterium A. baumannii, is particularly burdensome in clinical settings and is considered the highest priority for new antibiotic development. All right. A. baumannii, okay, well, yes. Yes. It's particularly burdensome in clinical settings, considered the highest priority for new antibiotic development. A. baumannii is notoriously difficult to eradicate, and it can cause pneumonia, meningitis, and wound infections, all of which can be fatal. New antibiotics are desperately required to combat A. baumannii because current treatment options are inadequate. Finding the right AI tools. AI methods have demonstrated the ability to identify promising drug candidates, including antibiotics. One type of AI method commonly leveraged in drug discovery is called a property prediction model, which is trained to estimate a molecule's inherent physical and chemical properties based on information derived from its structural characteristics. Property prediction models have been used to predict growth inhibitory activity against Escherichia coli and the antibiotic-resistant Burkholderia cenocepacia. Despite these successes, property prediction models are limited to evaluating molecules one by one from enumerated chemical libraries, which prevents them from exploring truly vast chemical spaces in a reasonable time. Alternatively, generative AI models do not analyze existing molecules, but instead build new ones, allowing for the discovery of novel structural classes of molecules. This is particularly important for antibiotics, where structurally and functionally novel molecules are desirable to overcome existing resistance determinants. While generative AI methods have been proposed and shown to be promising in silico, very few studies have synthesized and experimentally tested any of the hypothetical molecules. Also, Developing small molecule antibiotics has not been a focus of any of these prior approaches. All right. Synthemol. Kyle Swanson, a PhD student at Stanford, and Gary Leo, a PhD student at McMaster, co-led the development of Synthemol, which uses property prediction models and generative AI to create new antibiotics. Essentially, Synthemol employs property prediction models based on real-world data to assess the vast chemical space that generative AI models can mine for potential molecules. The researchers trained a property prediction model to predict antibacterial activity. They curated a training set of around 13,000 molecules against growth inhibition assays to determine their bioactivity against A. baumannii. The property prediction model guided the exploration of nearly 30 billion molecules synthesized using generative AI. Among the Synthemol compounds, the researchers synthesized and tested 58 structurally novel and diverse compounds. They discovered 6 structurally novel molecules with activity against A. baumannii. When combined with an outer membrane perturbing agent such as SPR 741 or colistin, it's colistin, all 6 molecules have broad spectrum activity against the diverse gram-negative species A. baumannii, E. coli, and K. pneumoniae. So they have broad spectrum activity against the diverse gram-negative species A. baumannii, E. coli, and K. pneumoniae, with one molecule, enamine 40, also active against P. aeruginosa. Okay, so we've got 6 molecules, broad spectrum activity against the diverse gram-negative species A. baumannii, E. coli, and K. pneumoniae, with one molecule, enamine 40, also active against P. aeruginosa. Continuing. As single agents, these molecules inhibit the growth of the gram-positive bacterium methicillin-resistant S. aureus and a lipopolysaccharide-deficient and colistin-resistant gram-negative isolate of A. baumannii, also tagged as ATCC 19606R. One significant disadvantage of Synthemol was that it was not programmed to produce molecules with high aqueous solubility. Only 2 of the 6 molecules could be tested for toxicity in mouse models due to the other 4 antibacterial molecules' insufficient aqueous solubility. While more research is needed to convert these generated molecules into viable antibiotic candidates and to improve generative AI models for synthesizable molecule design, this work represents a significant step toward the practical application of generative AI approaches for antibiotic discovery and drug discovery in general. Oh, look at that. All of the wonderful labels are at the end of the article. So it's under news, antibiotic resistance, antibiotics, artificial intelligence, bacteria, and drug discovery. All right, so you just heard Drug-resistant bacteria stymied by AI-designed antibiotics, published on March 24th, 2024, on GeneNGnews.com. That's GeneNGnews.com, which is the website for genetic engineering and biotechnology news. Again, those categories it was published under are News, antibiotic resistance, antibiotics, artificial intelligence, bacteria, and drug discovery. This article presented here today by Hakeem Ali Bokus Alexander for HAKEYM News on Noom Vibe and Spreaker in association with World Reading Club and UniquilibriuM. You can check it out for yourself by going to GENENGNEWS.com or check out the show notes on Spreaker, where you'll get some more full details, and also on HAKEYMnews.com or HAKEYM.com.